Welcome back. So, in previous lessons, we have learned about deserializing of time series, and now we're going to continue with the deserializing time series. We have learned on how to find the ratio between the average value and the actual value, and then followed by finding the seasonal index for each respective seasons. For example, for this case, I already given you seasonal index for summer, autumn, winter, and spring, which is 0.8609, 1.0772, 1.0692, 0.9927 respectively. And here, since here we have four seasons, the sum of all four seasons value, seasonal index value will be 4. For example, here you add up all the four seasonal indices values, which will give approximately 4. Now, let's say if not the summer value, the seasonal index for summer is does not given, just like this. So to find the seasonal index for the summer, you add all four seasons, you will get sum of 4. Therefore, to find the seasonal index value for summer, 4 minus other three values, you will get the seasonal index for summer. If you notice here, the number value 4 here is not fixed. It is based on number of seasons given. So for example, here I gave you 4 seasons, therefore it will be 4. In some cases, it will be given only 3 seasons. Therefore, the sum of 3 seasonal index value will be 3. If it is given as a 5 seasons, therefore the sum of 5 seasons will be 5. So the value 4 here does not fix. It will be vary according to the number of seasons given. So here there's only 4 seasons given, therefore the sum of the values will be 4, or sum of the seasonal index, all seasonal indexes will be 4. The given example is given as summer 0.8609. What does it mean? Any guesses or idea? If you notice just now, I said the sum of the 4 seasons is 4, correct? So means each seasons approximately to be 1. But here it is calculated at 0.86, which means it is lower about 0.1391 from 1. Therefore, the 0.8609 means the unemployment number in summer on average is lower compared to other seasons by 13.9%. So how I get this percent? 0.1391 multiplied with 100, so you get 13.9%. How if the seasonal index value is greater than 1? For example, here for autumn is 1.0692. Similarly, here it's going to be the unemployment number in autumn on average is higher compared to other seasons by 6.92. So here you can see if the value of seasonal index value is lower than 1, it should be a lower compared to other seasons, and if it is greater than 1, that means it is higher compared to other seasons. Or another way you can explain this, the index 1.0692 means that autumn have 1.069 times unemployment compared to the average on every season. Here we have already learned about seasonal indices, and by using seasonal indices we have learned how to deseasonalize each and every value for the respective seasons. On this example, I have given you the quarter number with the deseasonalized value. So now we are going to learn on how to find the least square regression to fit the trend line. If you still remember, the least square regression that we have learned in bivariate data by using our calculator. So here we are going to use the same thing. So to find the least square regression, key in the quarter number in L1 and this serialized value as L2, and then proceed your calculation for the least square regression, and you will get your gradient as 1.6 and y-intercept as 50.9. Since the question here they gave ask you to give the coefficient correct to one decimal place, so give it to one decimal place and it will be vary according to the question. And take note, your y-axis here is the seasonalized value and x-axis here is quarter number. Please be extra careful when you write this. Please don't write the actual value or the given value as a quarterly washing machine sales or washing machine sales, and your x-axis must be as your time series. For example, here I gave you quarter number, therefore my x-axis here will be the quarter number. If I gave you seasons, for example, autumn, winters, summer, so it will be seasons, not quarter number. So the x-axis here depends on the what they gave you as your timeline, and for your y-axis it is almost fixed, it will be deseasonalized value. Now we're going to use the least square regression to predict the future value. Okay, so here my question here I said forecast the sales of the washing machine in fourth quarter of year 4, giving your answer nearest to the whole number. So previously we have the least square regression, so we are going to use that least square regression to predict the future value. So here I already have for serial index for quarter 1, quarter 2, quarter 3 and quarter 4 together with the deserialized values and the quarter number. So here my question here is for fourth quarter of year 4. So for year 1, first quarter is 1, 2, 3, 4 and it's continue for year 2, 5, 6, 7, 8, followed by year 3, first quarter is 9, second quarter is 10, third quarter is 11 and fourth quarter is 12. And then when you go for the year 4, the first quarter will be 13, second quarter will be 14, third quarter will be 15 and fourth quarter will be 16. Therefore, from the previous slide, the deseasonalized value is equivalent to 1.6 multiplied with the quarter number plus with 50.9. Therefore, here we're going to substitute the quarter number with 16. And you calculate the deseasonalized value here is 76.5. Remember here, the forecast sale here denotes to be an actual value which is going to be sale in a fourth quarter in year 4. And deseasonalized value is not the actual value. Therefore, we are going to use our formula to find the actual value. So the deseasonalized value is equivalent to actual value divided by seasonal index. Therefore, to find the seasonal index, we are going to find the actual value is equivalent to deseasonalized value multiplied with seasonal index. So here we ask for the fourth quarter, therefore we will substitute with the fourth quarter's seasonal index. Therefore, deseasonalized value is given as 76.5 multiplied with the fourth quarter seasonal index 1.18 and the actual value will be 90. Let's say I asked you for the third quarter, therefore we will use the third quarter seasonal index. If the question asks you find the validity, did you still remember previously I mentioned that if the value is interpolated, then the prediction is reliable. If the value is extrapolated, it is non-reliable. But for this case, we cannot have any values in between the quarters or seasons. So what we do, if we are predicting the near future, for example, here is going to be the year for fourth quarter. So year 4 is near future to the year 3, or actual value or near value for the actual value. Therefore, this actual value 90 is reliable. If the question asks you to forecast or predict for year 6 or year 7, which is far from actual value, then it is not reliable. Remember, so for forecasting time series, it is one we see whether the value is inside the range or not in the range. We will look into whether it is a near future or not. If it is near future, then the actual value that we obtain is reliable. If it is not near future, it is not reliable. For this case, year 4 is near future, therefore it is reliable. If they ask you for year 5 or year 6 or year 7, it is not reliable.